Good morning, student. Let us see the remaining sums in exercise 3.2, question number 7. In triangle ABC, if quad A plus quad A, quad B and quad C are in AP, means arithmetic progression, then show that A square, B square, C square are also in AP, means arithmetic progression. We know that if three numbers, if X, Y and Z are in AP, then we have y is equal to x plus z upon 2. Similarly, quad A, quad B, quad C are in AP. This is given. Therefore, quad B is equal to quad A plus quad C upon 2. Therefore, 2 quad B is equal to quad A plus quad C. That is 2 cos B upon sin B is equal to cos A upon sin A plus cos C upon sin C. Therefore, 2 cos B upon sin B is equal to sin A into cos C plus cos A into sin C upon sin A into sin C. That is 2 cos B upon sin B is equal to, this is nothing but sin A plus C upon sin A into sin C. That is equal to 2 cos B upon sin B is equal to sin pi minus B upon sin A into sin C, since A plus C is equal to pi minus B. Therefore, 2 cos B upon sin B is equal to, this is nothing but sin B upon sin A into sin C, since sin pi minus theta is equal to sin theta. Therefore, 2 cos B is equal to sin square B upon sin A into sin C. Now, by using cosine rule, 2 into bracket C square and sine rule plus A square minus B square upon twice AC is equal to B square K square upon AK into CK. That is 2 get cancelled. C square plus A square minus B square upon AC is equal to, here K square, here B square, here K square AC. This K square get cancelled, AC get cancelled, isn't it? Therefore C square plus A square is equal to 2B square. Therefore B square is equal to C square plus A square upon 2. This implies that A square, B square, C square are also in AP. Hence proved. In this way we can prove this question, 7 question, isn't it? Very simple. Let us see question number 8. In triangle ABC, if A into cos A plus B into cos B, then prove that the triangle is either right angle or isosceles triangle. This question can be solved by using sine rule as well as cosine rule. First we will solve by sine rule. By using sine rule, A is equal to K into sine A, B is equal to K into sine B, and C is equal to K into sine C. We will use. Given A into cos A is equal to B into cos B. Therefore, K into sine A into cos A is equal to K into sine B into cos B, isn't it? Now K get cancelled. We can write multiplying by 2 sine A into cos A is equal to 2 sine B into cos B. This is nothing but sine 2A is equal to sine 2B. Since 2 sine theta into cos theta is equal to sine 2 theta. Therefore, sine 2A minus sine 2B is equal to 0. Now use the formula. We know sin C minus sin D is equal to 2 cos C plus D upon 2 into sin C minus D upon 2. Use this formula here. We get 2 cos 2A plus 2B upon 2 into sin 2A minus 2B upon 2 is equal to 0. That is 2 cos A plus B into sin A minus B is equal to 0. This implies that cos A plus B is equal to 0 or sin a minus b is equal to 0. Cos a plus b can be written as pi minus c is equal to 0. Since a plus b is equal to pi minus c. Therefore, cos pi minus c means minus cos c is equal to 0. Since cos of pi minus theta is equal to minus cos theta. Therefore, cos c is equal to 0. Now, cos c is equal to cos pi by 2. Cos get cancelled. C is equal to pi by 2. Since cos pi by 2 is equal to 0, we know. Now, therefore, angle C is equal to pi by 2. That is, C is equal to 90 degree. Therefore, triangle ABC is right angled triangle. Now, sin A minus B is equal to 0. Sin A minus B is equal to sin 0. Since sin 0 is equal to 0. Sin get cancelled. A minus B is equal to 0. Implies that A is equal to B. Therefore, triangle ABC is isosceles GAD. Thus, the triangle is either isosceles triangle or right angle triangle. In this way, we can prove this question, isn't it? This question can be solved by using cosine rule also. We will solve by using cosine rule. Same question, isn't it? Same question can be solved by using cosine rule. See here. Given A into cos A is equal to B into cos B. Therefore, by cosine rule, we get A into bracket B square plus C square minus A square upon twice BC is equal to B into bracket A square plus C square minus B square upon twice AC. Isn't it? Now, this C get cancelled. This two get cancelled. We have A in bracket B square plus C square minus A square upon B is equal to B in bracket A square plus C square minus B square upon A. Do cross multiplication. A into A square into bracket B square plus C square minus A square is equal to B into, do cross multiplication, B square is equal to B square into A square plus C square minus B square. Isn't it? 2 multiplication a square b square plus a square c square minus a raised to power 4 is equal to b square a square plus b square c square minus b raised to power 4. Isn't it? Now a square b square and b square a square get cancelled. What is remaining here? A square c square minus b square c square is equal to, we can write this, transfer this to this, a raised to power 4 minus b raised to power 4. Isn't it? Now taking c square common here, a square minus b square is equal to, this can be written as a square plus b square into a square minus c square. Now transfer this to the left side. C square into bracket a square minus b square minus a square plus b square into a square minus b square is equal to 0. Now take out a square minus b square as a common. In bracket we have c square minus in bracket a square plus b square is equal to 0. This implies that a square minus b square is equal to 0, or c square minus a square plus b square is equal to 0. Isn't it? This implies that a plus b into a minus b is equal to 0. This implies that a minus b is equal to 0. This implies that a is equal to b. Means two sides are equal. Therefore, triangle ABC is isotriangle. Now here we get c square is equal to a square plus b square. This implies that one side therefore by Pythagoras theorem we can say that given triangle is right angle triangle. Thus the given triangle is either right angle triangle or an isosceles triangle. Hence proved. In this way we can prove by using cosine rule also this sum. Let us see the last question of this exercise, that is question number 9. Remaining question 10, 11, 12, 13 are not in syllabus. So this is the last question of this exercise. Let us solve this. In this way, we, after completion of this question, we can complete our chapter also. With usual notation, show that 2 into bracket BC into cos A plus AC into cos B plus AB into cos C is equal to A square plus B square plus C square. Solution: LHS is equal to 2 in bracket BC into cos A plus AC into cos B plus AB into cos C. Therefore, by using cosine rule, LHS is equal to 2 in bracket BC into B square plus C square minus A square upon twice BC plus AC into bracket A square plus C square minus B square upon twice AC plus AB into bracket A square plus B square minus C square upon twice AB. This is by using cosine rule. Now BC get cancelled, AC get cancelled, AB get cancelled. We have and take out 2 as common. 2 upon 2 in bracket remaining B square plus C square minus A square plus A square plus C square minus B square plus A square plus B square minus C square. Now this 2 get cancelled. Now do cancellation. A square B square plus B square minus B square plus C square minus C square. Now what is remaining? This is A square. This is plus B square plus C square, that is equal to RHS. In this way, hence proved. In this way we can solve question number 9 by using cosine rule, isn't it?